Dear students, we are now ready to discuss the ARDL bound test procedure introduced by Pesaran and Shin and Pesaran et al. First, we discuss the steps involved in ARDL bound test procedure. The first step is make sure that none of the variables is I2. None of the variables is I2. If any of the variables is I2, it invalidates the methodology. The second is formulate error correction model ECM, an unrestricted ECM, and we will explain the difference between restricted and unrestricted later. And this is a particular type of ARDL model. It's a particular type of ARDL model. Actually, as we have discussed earlier, it is a reparameterization of ARDL model incorporating co-integration is a concept which we have discussed. Third is determine the appropriate lag length. Determine the appropriate lag length. Fourth is ensure that the errors are serially uncorrelated. Errors are serially uncorrelated. Make sure that the model is dynamically stable. Model is dynamically stable. That is, while discussing the Johansson procedure, it means that the roots of the polynomial are all lie inside the unit circle or outside the unit circle depending on how you define it. And perform the bound test. Perform the bound test to see if there is evidence of long-run relationship between variables. And if there is a long-run relationship between variables, then estimate the long-run levels of the model as well as a separate restricted ECM, that is both the short run and the long run, and use the model in the seventh step to derive short run dynamic effects and long run equilibrium relationships. These are the steps in ARDL bound test procedure. Now let us see this in detail. From the model we have suggested, we know that ARDL model has lags of both dependent and independent variables. Now suppose that we have three variables, y, x1, x2. We have three variables y, x1 and x2. In general, we have k plus 1 variables. And let us consider first what is a conventional ECM for co-integrated data. It was a conventional ECM for a co-integrated data is delta yt is equal to beta 0 plus sigma beta I delta y t minus I plus gamma j delta x1 t minus j plus sigma theta k delta x2 t minus k plus phi z t minus 1 plus epsilon. And as we have seen earlier, z is the error correction term. Error correction term obtained from the OLS residuals in the co-integrating regression yt yt is equal to alpha 0 plus alpha 1 x1 t plus alpha 2 x2 t plus et yt, and that is zt minus zt is equal to this zt minus 1, you simply take log, and this is what we have considered earlier, and this is familiar to us, the error correction model for the single equation model. All the variables are in first difference, and this is the error correction term z. This is zt. So lagging 1 you have zt minus 1. The summation I j k, here it is from what to say 1 to p, here it is from 0 to q1, 0 to q2, like that. So in our analysis, let us see what are the steps. In the first step, we use the ADF or KPSS test to ensure that none of the variables is I2. None of the variables is I2. In the second step, once we ensure that none of the variables is I2, we formulate the model as delta yt is equal to beta 0 plus sigma beta I delta yt minus I plus sigma gamma j delta x1 t minus j plus delta x2 t minus k plus theta 0 y1 t minus 1 yt minus 1 plus theta 1 x1 t minus 1 plus theta 2 x2 t minus 1 plus et. And if you compare this with this is something like or very close to the conventional ECM. But the difference is, here it is a linear combination, a restriction is imposed. Here no such restrictions are imposed, theta 0, theta 1, theta 2. Now, a key assumption of the ARDL bound testing methodology is that errors are serially independent. To ensure that errors are serially independent, we should use the log of the variables by using any of the log length selection criteria. Now, once we have selected the appropriate log length, we expect that there will be no autocorrelation. Otherwise, you can test for autocorrelation using the BG test we have studied. Now, we also know that we have a model with the autoregressive structure, and we have to ensure that it is dynamically stable. And to ensure dynamic stability, we have to check for what is known as the roots of the polynomial. In the log operator, something which we have studied. Now, we are ready to perform the bound testing. The model is this, and the F test for testing the hypothesis is H0 theta 0 equal to theta 1 equal to theta 2 is equal to 0. Is equal to 0. And H1 is H0 is not true. This is our null hypothesis. Theta 0 equal to theta 1 equal to theta 2 is equal to 0. H1 is H0 is not true. Now, the difference is we replace ECM Zt minus 1 with Yt minus 1, x1t minus 1 and x2t minus 1. And as such, this can be considered as a restricted model and this can be considered as an unrestricted model. Now, the range etc. are same. Now, one practical difficulty when using the F test is the distribution of F statistics is not standard. So, exact critical values of F is not available when the variables are a mixture of I0 and I1 variables. Now, Pesaran et al. Supply bounds on critical values for the asymptotic distribution of F statistics, and they give a lower bound and an upper bound for critical values, and a decision regarding co-integration is based on the lower and upper bounds to test this hypothesis. Now, the lower bound is based on the assumption that all the variables are I0. Lower bound is based on the assumption that all variables are I0, and upper bound is based on the assumption that all the variables are I1. In fact, the truth lies somewhere between these two extremes. If F is less than the lower bound, F is less than the lower bound, variables are I0 and no co-integration is possible. If S is greater than the upper bound, we have co-integration. And if F is between upper bound and lower bound, the test is inconclusive. So, this is the procedure. You formulate the model and use F to test this hypothesis. If F is less than the lower bound, the there is no co-integration. F is less than LB means all are I0, no possibility of co-integration. F greater than upper bound, there is co-integration. Between these two, the test is not conclusive. As a cross check, we also perform a bound test of H0. Theta 0 is equal to 0 versus H1 theta 0. Theta 0 is less than 0. Less than 0. If t for Yt minus 1 is greater than I1 bound, upper bound, this support the conclusion that there is long run relation. If t is less than I0, that are all stationary. Now, this is the ARDL bound test procedure. And once we have F greater than upper bound, we can estimate both the short run and also the long run relationships. And you will get both the short run and long run coefficients. The advantage of this procedure is we estimate both the short run and long run as in the conventional ECM. And one more advantage is it is a single equation method. And among the softwares, EV software provides easy estimation procedures, EVs 9 and higher. And comparing F with this lower bound and upper bound, you can take a decision. Also, the software will give you the long run relationships and also the short run dynamics. That is all.